Okay, we have a project where we've got a client who's ordered a custom threshold from us, and this video is to discuss and document basically the process of creating this custom threshold from where we are right now to where we need to get to. So let's start with taking a look at what the client has provided us in terms of requirements. Let's do that now.
And I see you have one that's extruded aluminum. It's 14 inches deep, 49 inches side to side. I've got a draft seal number for that particular one here, I believe.
Okay, Vern, what do you need to do? Order it?
I don't have a decent picture of it to actually see what it looks like. I got this little side view of it, showing the kind of the side shot of it. And I can't see what this thing looks like looking down from the top.
I don't have any other data than what comes out of the manufacturer's catalog. What's the part number? Because it's unlikely I have a photo, but I'll look.
It's DS1400HA48.
Yeah, I don't have a video and I don't have any photos. Let's see if I, by some chance, have one in stock.
Your homeowners kind of, I don't know, they don't want anything looking too industrial. They've been shying away from a couple things. So I'm not sure if this has some of these thresholds, they're kind of flat with ribs on top, running side to side.
Yeah.
Some of them have these deep grooves.
Yeah. So DS 1400. Oh, you said HA.
Correct. Hotel Alpha.
Oh, I see. Yeah. Okay. So the difference is the height. The H is the half-inch, and I stock.
Mm-hmm.
For some reason, I have the quarter-inch in stock. The quarter-inch rise. The cross-section, it's not identical, but yeah, it's a giant saddle threshold. So depending on the viewer, it may be extremely commercial looking, or it may not.
Yeah, I have no way to really know what this thing looks like.
Yeah.
Just kind of that little cross-section view, which just kind of shows a little elevation of it.
That's cross-section, yeah, absolutely. So what I can do is get one of the quarter-inch rise pulled. It's not going to be identical, but it'll give you an idea of what it looks like.
Let's see, it comes in two pieces, correct? So I'm going to have to get those welded together, or do you weld those and then ship it as one piece?
Possibly to the former, no to the latter. And generally what happens is they're just installed as two separate pieces. But if you want it to be a single piece, I can definitely get...
the installation is going over, it's an old mansion of a house, 16, 18 inches thick walls. So this is there's no wood that will be under it. It's going over masonry, bricked and blocked and all sorts of stuff. So it needs to be one piece. Whether you have it welded or I have to get the thing welded, it needs to go installed as one piece. And I can't remember on yours if pre-drilled holes was optional, which I would not want because we're not drilling into wood. We're going to have to use some sort of adhesive to hold this thing down. And I'm actually going to be cutting that 14 by 49 down a little bit to make it actually fit.
Cutting it down in what dimension?
Oh, to about 48 and a quarter, 48.
Oh, yeah. You would just order it the size that you need.
Or you would custom build it to whatever I want.
The thing's going to be custom no matter what. So sure, absolutely. Without holes, welded, not welded, absolutely. Not going to stop at then having to, get a sliding compound saw that you'll have to still flip it over.
The one this picture I'm looking at, the two pieces, there's a drop on each edge of it, and would be cutting off. Yeah, I only need the saddle, the drop on one edge of it because the other would be butting in underneath the patio door.
Well, it sounds like you need a half saddle. You don't need it to be a full saddle.
Right. If that's what I'm not sure with your terminology, but what I need is basically 13 inches. With what sounds like what you call a half saddle.
What you should do is email me a hand-drawn sketch of what you want this to look like in the end. and that's the right way to go. This threshold's not going to be inexpensive, especially when we add the welding labor to it. Regardless of you getting it done or it coming from the factory, it'd be cheapest for the factory to do it. So that's what I'd want to start with, seeing what you want it to look like, so I can make the best attempt to match your exact requirements using parts.
Okay.
All right, sir. Give me a moment. I'll send you an email. I'm Richard. Reply back with something, and we'll get to work on it.
Ballpark. Well, a couple of questions. How long would it take to get something in my hand?
Best case scenario would be 3 weeks. That absolute best scenario.
Where are you located? Where would this be coming from?
Southwest Florida, and it depends on what your needs are. I'm thinking about Reese in Minnesota. Draft seals in Vancouver, that they're not going to be an option because of the lead time, it sounds like. Plus, I don't still do the welding.
Yeah. Ballpark price on this thing?
Hundreds.
Yeah.
A few. I wouldn't say several. But I've got to see what you want. It's
okay. All right.
The welding alone is probably worth $250 would be my guess. It's pure speculation. I just don't know.
Okay. All right. Sounds fair enough.
Yes, sir. Thank you very much.
Okay. Thank you.
Bye-bye.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
And before we get there, let's listen to the rest of the conversation that I know in terms of information that the client has provided, and then we'll switch to the screen view.
So you've got a need for a custom threshold. So we're talking about what's the overall height of this custom threshold and what's the wall thickness. So the overall height is obvious. The wall thickness is if you put a caliper on the aluminum itself, how thick is it? So if your overall height is a quarter inch, that wall thickness has obviously got to be well less than a quarter inch because of that angle that you have on the piece. And if it's half-inch overall height, then you can make that wall thickness, more typically 3/16. That's going to work. Okay.
Yeah. Yeah, we can do that.
Okay, so I'm not in a position to record any of this data because I'm literally at the machine. So, half-inch overall height, 3/16 wall thickness or thereabouts. And then the next question was, I think, what do you want the top to look like? Is it fluted or is it smooth?
Yeah, it needs to have, side to side, like ribs, whether you call that extruded or whatever you want to call that. Yeah.
Yeah, absolutely. That can be done, so it's not a problem.
Yeah, and then that, I don't know what you call that little drop down where it comes out at the end, the little flange drop down. You've got your own name for that, whatever that is. I don't know.
Well, that threshold is actually a half saddle, is what it is.
Yeah.
So you're building a half saddle with a custom width, and that's all there is to it.
Yeah. Okay, so that gives you enough information to kind of work up a price or something then?
Well, it does, but reply to the email because I'm in the shop.
Okay. All right.
Yeah. And I'll get working on a price for it.
Okay. And you were thinking somewhere in the 3-week range? I trying to recall what you had said.
I would think that would be reasonable, something like that, but I'll get it from the factory once we incorporate the shop labor, is what I'm trying to say.
Yeah. Okay. All right. Very good.
Excellent. Thank you, sir. I'll be in touch soon.
Okay. Thanks a lot, Rich. Yeah.
Fine.
Bye.
So here's what the client has provided us in terms of my request for a sketch, and here's what we're looking at. So, and there'll be a couple of photographs, but 13 3/8 overall is what the client told me. I believe 13 3/8, and the length was about 4 foot. I forget the actual length. It may have been 44 inch, 43 and something. So this is really important to start with, along with the images that the client has provided. So I'm really thinking that this is your 12 3/8 that you're dealing with. A little bit of hangover to clean off the front end. Yeah, so that's face brick there. So it makes sense that you're going to be about 12 3/8. Now it's really interesting when you consider the custom fabrication of something that's going to be a threshold. And interesting component is the methodology by which you go about determining how to make this piece of item, not when you're extruding it, but when you are milling it on a CNC machine, which is what we're actually going to do, right? So let's take a look at a manufacturer's catalog and let's talk about those things that are important when it comes to the design of a threshold, or at least according to me, I guess, what's important in the design of a threshold. Let's do that now. And in the process of determining what's important, let's look at a manufacturer's product catalog. I like Reese. I like them for lots of reasons, but what's interesting is what the client wants, the manufacturer can't provide, in the sense that the client wants a half saddle threshold without, from what I believe, supports underneath. So a manufacturer is not going to take this sort of plate, and every manufacturer is going to have some support underneath their material, and without giving the client supports underneath or going without this lip, there's just nothing out of the catalog that's going to suit. And what the manufacturer like Reese and others, National Guard, Pemco, Draft Seal, Dorbin, anybody who supplies weather stripping, they're going to be limited by what they can do. They can cut, they can rip, and they can weld, but there's limitations in terms of what they can rip, from what I understand. So if the client were to take and need, again, about 13 3/8 overall width, a half-inch tall half saddle is what the client needs. As we scroll through here, we just don't see anything nearly wide enough. The problem is, if we were to take, something like this and rip multiple pieces and weld multiple times, in theory it would work, but the requirements that the client has when they're all brought together really exceed what a manufacturer can make. However, taking a piece of half-inch thick plate aluminum in a 6061 alloy is something that we can absolutely give them what they want. So I was talking about what are the important characteristics of a threshold. Well, you'll see that there are smooth thresholds and then fluted thresholds. Flutes, not pocketed or square, but almost so. Ball, end, flutes, smooth, okay? And the client definitely wants a fluted top. That's been discussed. Now, the important characteristics of a threshold to me are going to be usually a fluted top of some type versus smooth. I've lost my footing on a smooth threshold in the past. They're slippery when it's wet. A fluted threshold definitely helps. So some sort of treatment to the top. A substantial enough wall thickness to accomplish the project, meaning you want the threshold to be durable and to do the job for which it's being asked to do. So a thick enough extrusion is what the manufacturer is going for. I like to have these serrations underneath here. Now that's a really handy detail, and you'll note that this model does not have it, but I like having the serrations, and you'll note that this super heavy-duty threshold has them. You'll note that they're bump-up style thresholds, and a very common style of bump-up threshold is the S488 would be a really common one. These serrations do a couple of things. They allow you to resist the lateral force of the door hitting the bump-up aspect of the threshold every time, resisting it moving laterally. Also, gives it a nice area for the caulk to reside in to help keep water from intruding. So those serrations are really nice. Now, the conversation really becomes of how do we go about thinking of creating the steps by which we're going to custom CNC mill a threshold for a client. And having spent a lot of time thinking about it, but also discussing it within the inner circles, some really interesting concepts have come to light, and allow me to share those with you now.
If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it.
Now, we were just talking about the important components to a threshold, and some sort of most likely fluting to the top of the threshold is necessary. Not always, sometimes they're smooth. I just don't sell a lot of smooth thresholds, and as I said earlier, I know that my feet have slipped on those. Catch the heel and it's wet and it just slides. So some sort of fluting is done to the top. You'll note that what Reese is doing here looks like a ball, but you'll take note of these three thresholds, here, here, and here. Each one of them has a successively larger ball, and that's because they're successively thicker material. I don't know the wall thickness of each of these three, but if the drawing is reasonably to scale, then the 2048 is thicker than the 424. Now, what's really interesting about that concept, along with the serrations, along with it having the proper support underneath, given the application, the proper ADA compliant sort of arrangement here, is thinking about the concept between extruding, which is what Reese and National Guard and PEMCO and everyone else does, and milling out of solid plate. So where that starts with is the mental exercise of thinking about the approach of producing a threshold when you extrude it versus thinking about the approach when you think about milling it are two very different approaches. And what's really important here is, well, I don't know that it's really important. Aluminum extrusions shown are alloy 6063-T5. They're available in mill and other finishes. Okay, so it's the alloy 6063, and the T5 is a reference to the tempering. Aluminum 6063. 6063 is a medium strength alloy that is often referred to as architectural aluminum. It's used in intricate extrusions and is known for its good surface finish, high corrosion resistance, and the ability to be welded. It is also rated as good, not excellent or fair, for forming and cold working applications, and excellent for anodizing, but only fair for machining. So that's 6063. It turns out that 6063, if you're going to extrude, is really the product to use, and it gives you the excellent rating for anodizing. Now, 6061 is the alloy that's known for people that are going to work on a CNC machine. And the question becomes what is 6061? 6061 aluminum is a precipitation hardening aluminum alloy. I don't know what that means. Contains magnesium and silicon and its major alloying elements. It is one of the most common aluminum alloys for general purpose use, good mechanical properties, and good weldability. It is also heat treatable, resists cracking due to stress, and is easy to weld and machine, but limited on formability. Now, I have read elsewhere that 6063 is used because it's specifically conducive to the extrusion process, where 6061 is specifically used because of the machinability. Its predisposure to being easily machined. The other alloy that is used for machining is also 7075, and 7075 hardened to very high strength levels. It's strong, good fatigue strength, and average machinability, but is not weldable and has less resistance to corrosion than many other alloys. So I wouldn't opt to use 7075 because average machinability, I want it to be easy to machine. I do want to be able to weld aluminum, even though I don't do it. I've not taught myself how to do it. I can weld steel, I can MIG weld, I can oxyacetylene weld, meaning I've done all of this. I just never learned how to TIG weld. If that comes up, then we'll look at it. So 7075 would not be an alloy that I would choose to use because harder to cut and I can't weld it. So 6061 is what we're going to use because it's known for machinability. So the point of all of that is the approach to thinking about the aluminum and the process to making the material is wholly different between extruding and milling. Now, to start that conversation, let's look at our example again. So when we're thinking about extruding aluminum, the manufacturer is certainly going to be thinking about being competitive within the marketplace. I can't really say why the size of the ball or the flute is important to being anti-slip. Perhaps the ball or the fluting, because it's not always ball shape, could be more like this, partially trapezoidal. maybe that certainly serves as an anti-slip, but maybe some slippery person decades ago realized, this is how I can save money. Maybe thresholds once upon a time were all solid. And someone said, well, wait a minute, we can make that less expensive if we change our die set, and we'll tell them it's slip resistant. Maybe that's something. But you'll notice how the balls get larger in every single size, and I'm not thinking that this is necessarily less slip resistant than this, because I don't know how the height of this really matters to the diameter of the fluting that you're doing. But what I do believe is that the manufacturer is using the ball groove or the fluting as a means by which to use less aluminum. However, they're also obligated to produce a strong product. This is quite a thick extrusion. It's probably 1/4 inch for sure. This is probably 3/16. But you'll note when they get really thin and they flute, they're actually adding aluminum to the bottom of that. So there's clearly some science that they've learned. If it gets too thin, it's not going to last. It'll crush. Foot traffic will destroy it. So when you're extruding, you're really thinking about how can I achieve my purpose, sell a quality product economically, and something that's going to be durable and last, but something where I can save aluminum, meaning make it as inexpensive as possible and again, still achieve what has to be achieved. Now, from the prospect of machining a solid piece of aluminum, this is a initial drawing that I've done for this client. I'm going to redraw it later in this video. But this piece of aluminum starts out like this. Line here, 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 here. Okay, so this is what our piece is going to start out as, and I want to select that so that you can see it. So now, so that's what our piece of aluminum is going to look like. We're starting out with a block of aluminum. So for us, in order to get the piece that we want looking like that, we need to remove a lot of material. Well, to the extruder, they want to provide the least amount of aluminum, I would imagine, and still provide a good quality product. Absolutely. From my perspective, I want to remove the least amount of material because it's easier on me. There's less to remove. Now imagine what's going to have to happen to make this 13 3/8 wide piece of 1/2 inch thick aluminum. We're going to have to first run a V-bit to create this profile, and then all these pocketing profiles. I think it's about 4 foot long. It's a lot of pocketing. Then we're going to have to flip it over, and we're literally going to have to run a V-groove here, so it'll actually look like this, and then pocket all of this. So if this is 1/4 inch, and this is 1/4 inch, wow, that's a lot of aluminum. If the client were to say, you know what I would really like? I would really like it to be a piece of solid aluminum, where it would really just look like this. And if the client said that, well, gosh, our amount of machining just went way, way down. The issue is a piece of solid aluminum may not serve the needs of the client unless they tell you that meets my needs exactly. It just wouldn't in this case because the client does want this flat portion to sit on their sill and this to hang over the lip of the sill or the front of it, probably to disguise it and to break it as well. So thinking of machining or milling is really the opposite approach. The extruder wants to prevent more going into it from the beginning, and the machiner, like me, wants to prevent taking away in the beginning. So now this is the initial drawing I sent to the client. I'm going to now draw another one because this relationship is not code compliant with the rise over run. And I have a V-bit that ought to be able to comply with that. So let's move on and redraw this.
If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video.
could very likely be our finished threshold. I'm going to screenshot this and send it to the client and ask for approval. And then the next video, as we move forward, I'm going to talk about how we're going to make this in theory, and then we're going to move to tool pathing this in VCarve in the Vectric software. We're starting with a block of aluminum. So when you visualize a 4-foot by 8-foot long sheet, half-inch plate of aluminum, how are we going to machine this? So as far as I'm concerned, we're going to put this V-bit tool path first, and then we're going to run the end mill 16 times, the entire length. Then we're going to flip the piece over, and we're going to put the V-bit here and run that, and then we're going to pocket the rest of all of this out of there. Maybe I'll run the V-bit to remove a lot of it, because pocketing a 1/4 inch thick, 12 3/8 wide, it's going to take some time, because our pass depth is only going to be maybe a 1/16 of an inch. So 4 passes deep, 25 times wide, 100 passes on the tool just to pocket out this area, plus the 4 passes on the V-bit. So 104 passes on the bottom of this is what this is going to take. The top is going to take 4 plus 16, 21 passes, so 125 passes on the tool. If this was what I was going to make, it'll be 125 passes. Okay, let's now move on to tool pathing this in the software. And actually, what I think I'll do is I'll grab this as my vector and import that into the VCarve tool.
Thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.